All right. True and true. We're going to need the normal probability outlet. Use the normal probability outlet to find the combined area under the standard normal curve that is to the right of 1.358 and the left. Okay. What was it?
Do you get 0.175?
1.358. Just a second, I haven't done it yet.
Oh, you get.
1, 3. Okay, to the left and to the right. I got 175.175.
Yep.
Yes.
Okay, which of the following have the smaller standard deviation if 9 observations are randomly drawn from the population? The distribution of individual operations, the distribution of sample means,
The following have a smaller standard D. 9 observations are randomization.
Observation, distribution of sample means. I really don't know.
No, let's see.
Let's see. I'm gonna check out the textbook, see if I can figure it out.
Individual observations. Sample. Oh, what affects I don't think you're making term.
All right, so let's think about it. So how do we find the standard deviation of individual observations?
Let's see.
So let's see.
Oh, didn't we learn about this last week
Probably.
or the last lesson?
Which
So
the deviation would be figured out by that divided by the square root of the
yeah, the distribution of sample means. So let's see here. Here, I'm gonna open something up.
the sample size.
So, I mean, the standard deviation of a population, let's just say it's 2. And then to find the standard deviation of a population, if we have 100 sample size, the standard deviation is going to be 0.2. So the smaller standard deviation is going to be the distribution of the sample mean. I mean, we can put this in line. I think it should be the sample mean.
If it's referring to like distribution, it says that the standard deviation is found by standard deviation divided by the square root of the sample size.
You're still in 5?
Yeah. Are we like all on agreement with the answer then, or?
I'm on 4.
Oh, 4.
Yeah, well, on question 4. Yeah.
Yeah. I put B, middle one.
So B, I'm saying B too.
Okay. Number 5, I think it's the, well, obviously either the central theorem or the law of large numbers.
Yeah.
I'm inclined to say the law of large numbers because central limit theorem deals more with the shape of the curve, and law of large numbers has more to do with the mean, so that the spread of the mean decreases, the sample size increases. I think that is the law of large numbers.
Okay.
What do you guys think?
Well, it implies that the spread decreases and the sample size increases. Hold on a sec.
Talks a lot more about the central limit theory.
Yeah, it does.
So maybe focusing more on that. So based on that, I would choose the B. Let me see the other lesson.
The following results are given the spread in X, which that is the random variable.
Let's see. What's the large numbers?
So, are you guys still working on number 5?
Yeah.
Okay.
Mm,
Yeah, I don't know. The only reason I'm more inclined to say that central limit theorem is just because it talks more about it in lesson 7. But then again, like in the last lesson, I did talk about like
mhm. Now large number states.
the numbers being closer to each other as opposed to like the distribution or like the curve, the shape of the distribution. Well, that's
Yeah.
more the central limit theorem.
Well, does anyone have the definition of central limit theorem pulled up?
See.
I thought I did have lesson 6 open, but I closed it. Alright, let's see.
What it means by the spread in X, it means that it becomes more normal.
Yeah, this closer to, so the standard deviation of mean. So you're going to take a bunch of samples, and each sample is going to have a slightly different mean, right? So you take 5 samples, and they're all going to have a different mean. So let's say one has a mean of 0.9, the other one has a mean of 1, the next one has a mean of 1.1. What you do is you add them together, and you get the sample mean, right? So what the central theorem statement says is that if you have a large enough sample size, the curve of your sample mean will be normally distributed. And I'm pretty sure the law of large numbers is the closer, given a sufficient size in sufficient sample size, the mean will be approximately, or will be closer to the mean of the population. So
Yeah, it says it right here. So central law theorem states that if the sample size is large, that X will be approximately normal. The law of large numbers states that the sample mean X will be close to U, which sets the population mean.
Yeah.
right, well, is that X bar or X?
No, X bar.
X bar.
Okay.
So I think it's the law of large numbers.
How large numbers?
Give it a try.
Okay. Yeah.
I'm having a hard time with number 6 because I'm not sure what the population is.
What the sample size, what the sample is, right?
Yeah.
Yeah, I don't know what it is either because it doesn't give it to you. So we
Yeah,
just
because I'm trying to figure out, because I'm
this
using
old way.
I was trying to use value minus mean minus
Yeah,
oh, you know
divided
what?
by-
We don't need the population size because they already give us the standard
I
deviation.
think it's only 160.
So it should only be value.
So 160 minus 150.8 divided by the standard deviation. So what is that?
So do you get 1.045?
Just a second.
No, you
Yeah.
get.
160, right? What was the answer you got?
One moment. Sorry, I'm fixing my Excel spreadsheet here.
I got what's 3 decimal places?
Uh-huh.
Yeah, it's 3 decimal places. Oh shoot.
So 1.045.
Yeah, that's what I got too.
Okay, so it's going to be value equals, let's see, so the value of this is 160, and then we minus the mean out, and then we divide that by the standard deviation, right?
Mm-hmm.
Is 8.8.
Yeah.
Okay, so I got
What do you get again?
1.45.
Okay.
Yeah, 1.045.
Doing
Yeah,
the same.
1.045.
Awesome.
All right, so probability random selection above 160. Above 160. So I guess we use the probability output for this. We put the z-score in there.
And what is the probability that a randomly selected student will score above 160?
It's
So
0.048.
Yeah. About 0.1.
you said it was 4.5, right? Okay, so 14.8.
Wait, what was your answer again?
Okay, let me double check this.
Did you say 0.148?
No, 1.148.
Right, okay.
Okay. A random sample of 5 students. What does the z-score correspond to the sample? Mean of these students' scores. Okay, so can you read these off to me?
Right, so 160,
Okay.
175, 163, 49,
49.
yeah, 149, and then 153.
Okay, so 160, 175, 163, 149, 153.
Correct.
And we have to calculate the media.
What is the z-score upon corresponding to sample mean in the students?
Mean is 192.
Okay, so the average is 160.
It's 160?
Well, the mean of the whole student is 160. So we still have to,
So it's the same.
well, they want the standard deviation.
You want the z-score?
Yeah, they want the z-score. So we have to take the,
So do we have to find,
we have to take 160, subtract the 150.3, right?
Let's see.
z-scores corresponding to the sample mean of student scores? What's this?
Oh, it's 1.8. I mean, it should be the same as hers because I got 160. So.
So the mean is the number in the middle of other numbers or just the
It's the no.
It's
It
the
would-
average.
average?
Yeah, it'd
So you
be
have to
all those added divided by 5. That's how you would find
Yeah.
the real mean.
So you get 192, right? No, sorry.
I got 160 here.
Right.
Let me do it the long way to make sure that I did it right.
You're fine.
Okay, so there's 5 numbers equals this divided by 5. Yeah, I got 160. So,
So it would be the same.
So it's the
yeah,
same.
it should be, the answer should be 1.045.
It's funny.
Okay. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
So what? How much you get? What do you get at 8 again?
This should be the same answer. Same answer as the first one
Yeah,
that
it
we
should
did in
be
this.
0.148 because it's the same
Yeah.
average.
4.48, right?
It's really strange that they would do that. I'm weary about that.
Oh, 4.8, right? Yeah, 4.8.
Yeah, 0.148 because
Uh-huh.
I mean you
Because
put
it
that in the
would-
probability applet.
Right, no, that
So-
one wouldn't be 1.48. That would be the same answer as 6.
Yeah, it would be the same answer as 6.
Yeah, 1.1045, not 1.48.
But in
Wait,
7
wait.
you have
The
7 you have the
probability-
value of 10, right?
Because we're finding the z-score,
Probability-
not the area or the probability on 8.
Oh, okay. So wait,
Yeah.
so what is the probability that the 5 randomly students will have a mean score? So we're looking for the probability, not the
Yeah, on this one it's probability. So I don't know. So it'll be this. Yeah, that would be 1.48 too.
yeah, 1.4, and it wants us to round out to 8 or 4 decimal points, and so 0.1480 because that's what the applet gives me. So
Heck, man.
weird.
All right. Well, question number 10. What was GPA?
All right, well, let's move on to number 10. Well,
Okay, this is the one where we find the z-scores there. Okay, what is the shape of the sampling distribution variable x, which represents the sample mean? 81 students are selected.
it should be approximately normal, right?
Yeah,
Because it's large.
yeah, it should be approximately normal. Because a larger number.
What is the mean of the distribution of the sample means for all possible samples? Size 81 could be drawn for the parent population. Okay, so what's the value?
Post and mean is 3.5. What is the mean of the distribution?
What is the distribution of sample means?
Okay, let's see.
I don't know. Would it be that?
Okay. So B, let's see here.
Wait. So let's see. Okay, the sample size is 81. Does it give us the standard deviation? 0.7. Point. What is the mean distribution of the sample size? Oh, well, it'd be 35, right?
Well, 3.5.
Oh, 3 point. Yeah, the mean is 3.5.
That's what I'm thinking it is. I don't know what else it could be.
Yeah, I always overthink those. Okay, what is the standard deviation of the distribution of the sample means? So that's the one where we have to.
Yeah, that's the. Yeah, we need to do the square root of 81
So it's point
divided by the distribution 0.7 divided by square root of 81.
It's 0.078.
Well, isn't it the mean minus the standard deviation divided by the square root?
That's the z-score.
Ah,
Yeah.
standard deviation.
So it should be 0.0078
Yeah.
or 0.0.
All right, let's see here. Okay, so it's the standard deviation divided by the sample size. Okay, so 0.7. And then
Probability.
all right, so I got 0.07777777.
Yeah, so 0.078.
0.077. All right, what is the probability that the mean GPA for 81 randomly select will be less than 3.3?
So I'm guessing we would have to find the z-score for.
Let's find the z-score. So the value is 3.3. So the z-score, so the value is 3.3, the mean is 3.5, standard deviation is 0.7, sample size is 81, right?
Yeah, we already got the deviation, so it should be 0.078 as your denominator.
So it's 3.3 minus 3.5 divided by 0.078. And that's
I got
the z-score.
2.571. Seems pretty small.
What was it again?
I got 2.571.
3 or 2?
2.571.
Got 2.5641.
Yeah, I get it.
All right, well, let's see.
If we run the
mean is 3.3, and I subtract. I mean, the value is 3.3 and subtract the mean of 3.5, right?
Right. And divide it by. Yeah, that has to be minus first, and then we can divide it by the denominator of
Standard deviation that we just got.
It might be different because are you doing it by it rounded or?
Yeah, if you
Well,
run the
do it
numbers,
in
it's
Excel.
different.
Because that's probably why you got a different method. So I don't know
Yeah.
which one you would have to use.
So are you and I getting the same score, Z-score, Jordan?
Well, I think the only problem is that I don't know if you're using the whole. So you know how you found the standard deviation before, and it gave you like 177777778 or whatever.
Yeah.
I of it. So I'm dividing it by the rounded version, not the whole version. So maybe that's, I don't know if we have to do it that way.
Well, they say don't round your calculations until the end.
Oh,
Okay,
okay.
so we would have to do it that way. So
Yeah.
if you've done it that way, then the one you have is the one that we need to use.
Yeah.
So,
So you get the
Just to review,
2.571,
let me
right?
tell you what I've done. I took 3.5, subtracted 3.7, divided it, and divided that number by the standard deviation we found earlier, which is 0.0777777778.
and you did a 3.3 minus 3.5, right?
Yep.
Okay. All right, and then what was your Z-score?
The Z-score is negative 2.514286.
Negative 2.51.
2.5714286.
So we'll
I
leave it at
got
2.571.
0.051.
And then what was it asking for? Probably the mean sector will be less than 3.3.
Wow. BYU students have really good GPAs. If you're not going to, if less than 1% of your students have less than a 3.3 GPA.
So what's the overall answer?
What'd you say?
The answer for this question?
I put 0.005.
0.005. And you got that through the probability output, right?
Yep.
Yeah.
I put in
So it's
0.005. Yep.
is the area to the left, right, from the
Yep.
Z-score? Okay.
0.05. That's it. Okay, and then 14 probability will be greater. So that would probably be the same thing, right?
Okay, what is the probability that the mean?
So it's everything to the left, to the right, pretty much.
Will be greater than 3.3, so we just need to unshade the thing to the left. So 99.5.
0.995. Okay.
.995, right?
Uh-huh. Yeah.
All right, the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous volume was lower, but was raised after a tragic boating accident. Standard deviation of passenger weights is 26.7. The weights of random samples of 48 commercial boat passengers were reported. The sample mean was determined to be 177.6 pounds. Find the probability that the random sample of passengers have a weight that is extreme or more extreme, either above or below the mean, than was observed in the sample. Round your answer to 3 decimal point places. If the answer is yada yada yada.
Uh-huh. Cool.
Okay,
Let's
so what do we need to do here? The value is going to be 177.6, right?
Yeah. That's going to be minus 185. And then
Let's see, the standard deviation is 26.7.
yeah, the square root of 48.
right, I got a z-score of negative 1.9,
1.9.
negative 1.92.
All right, so let's see. Let's make sure I do it.
Let's see, what is this asking again? Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean.
So the left or right, left and right, right? Not in the middle.
Yeah, so the left and right. So I guess you would put the z-score in and then add up the area and it would be 0.055. That'd be my guess.
Hold on 1 second.
What's your score again?
My z-score,
Yeah, it's 1.972.
negative 1.92017618.
Oh,
You get something different?
oh, yeah, I know what I messed up. Okay, let's see.
I got something different too.
Yeah, let's. I don't know why I got my CS score. Well, 1.9201.
Yeah, 1.9201.
Okay, cool. So 1.920. Oh my goodness.
No, okay. Not sure what happened there. Divided by that.
So the answer should be 0.9726.
0.9726 is what?
Is that the answer?
No, it's 0.055 because if you go to the applet and you enter in the z-score at the bottom and you click the left and right spots, then the area is 0.0549 and it rounds up to 0.055.
Oh, it's so we calculate only the ones
It's on the on the low extreme and the high extreme.
only the streams. Okay.
All right. Well, cool. So are we ready to submit this?
Yeah, hopefully we got this down. I mean,
Okay, I am going to submit it.
One more thing. What do you have for? Let's see, just to make sure. Which one is the one? What do you have for 9?
9? In a second.
9 was one. Was that same answer? Remember, like how those are all the same answers, but it's just one more zero to it, so it's a 0.1480. Because the probability is going to be exactly the same since the z-score is exactly the same as the last answer, so they're just going to be identical answers.
So it's 1480. 14080. Okay.
Exactly. So it's 0.1480.
Perfect.
Okay. We got a 15 out of 17.
There's only 15 questions.
Oh, well, I got a 15 out of 17.
Which one did you get wrong?
Let me see here. I'm looking for zeros.
Let's see.
Okay, question 9, I got wrong.
Okay, so it's not an answer then. That's weird. Okay.
Question 8, I got wrong.
So we got those two wrong. Those are probably the only two, right?
8 and 9, right? Yeah, me too. Of course, we also made it the same. So, okay, I'm gonna take notes of the right ones.
Z-score corresponding with the sample students. Sample mean of these students.
Okay, let's do this again. Mhm.
Heck.
Oh, I know what to do here. So, oh wait, maybe I don't. What is the Z-score?
The thing is, what is the random, what is the variable that we're trying to find? Because it says to the sample mean of these students.
Oh, hey guys. I think you guys should probably submit your quizzes
Oh, yeah.
because this is going to be our second attempt.
Uh-huh.
So I think just name of honesty should, because the professor's asked us not to do what we're doing right now.
Right,
So,
yeah, don't, yeah.
yeah, so.
Okay.
So Z-score corresponding to the sample mean of these student scores. The sample mean is just these 5 scores averaged out, right?
That's what I'm guessing. So, but is that
It should be 160.
So would it be
Okay.
160 minus 160? Or are we still minusing by the...
Well, I mean, the mean
Is
is
150?
150.8.
So... I don't...
And I mean, the value must be the sample mean, right?
That's the only thing that makes sense, because there's no other way or means to know what number you're supposed to use.
And I mean, the standard deviation, 8.8. And sample size, I mean, is the sample size 5, right?
Yeah.
Oh, maybe that's what we did wrong then. Yeah, that's exactly what we did wrong.
That must be what we did wrong. All right, let's see here. So,
Okay, I'm gonna put the equation.
probability. So the Z-score is, wait, so is it asking for the Z-score?
Uh-huh.
Yes.
Well, question 9. Oh no, question 8 is the Z-score. So the Z-score I got now is 2.3377.
So it's 2.338 rounded.
2.338. That's what I
Okay,
got.
gotcha.
And then that means we just need to take this into the normal probability applet
Uh-huh.
and put in the Z-score of 2.338. And then what is it asking? That they'll be higher.
Uh-huh.
So we just need to click on everything to the right.
So it should be
So it should be 0.0097.
perfect.
All right. So I'm still on the grading
0.0097.
thing. So do you guys have those answers put into another quiz? Do you have them written down? Things that I just said?
I wrote down all the answers for the quiz. So
All right. So let's go through and fill them back in together.
Yeah.
And
What was number 8 again? 2 point.
2.33.
Number 8 is
2.
2.3378.
2.3378. What did I do wrong with this?
So you just round it.
Okay, let's see here.
Okay, let's see. I'm gonna put everything there.
Okay, I'm navigating back to the quiz. I'm sorry. I have church Wi-Fi, so it's
Good.
a little slow.
Being that number, I don't get it.
All right.
You still do okay.
It started the
2.
quiz.
778, right?
It's out of 17, yeah.
No, I mean the number 8, 2.778.
Yeah, number 8 is, oh, well, that's the Z-score, right?
Yeah, and
That we
then
got
the probability was like
I have
0.097.
2.338. Or, well, let me read the whole thing to you. It's going to be, the whole Z-score is 2.33770743 is what I got. So,
Or 2.338.
yeah, 3338. Yeah, 338. Okay, will you please read the answers back to me on the questions, and I'll just fill them in.
Okay.
So I'm on question 3.
So 3 should be 0.175. 0.175.
0.175.
Uh-huh. Then 4
Right,
should
and
be B.
2.
Sample means right, B.
B. Uh-huh. Then 5 is the low large numbers.
All right, save. All right, what's number 6?
It's 1.045.
1.045. Number 7.
It's 1 point. Wait, just say that one again.
Number 6, 1.045.
Okay.
Okay. Number 7, it's 0.148.
0.148. What's 2.338? What was this one again? Number 9?
It's 0.0097.
Okay. All right, let's see here. This was, they were left skewed. What was the shape of the sample?
No, it was approximately normal.
Approximately normal.
Oh, yeah, sorry, approximately normal. Yeah, I wasn't reading the question anymore. 11?
Should be 3.5.
3.5. Number 12?
0.078.
0.0278?
078.
078. Okay. 0.078.
Mm-hmm.
13.
Should be 0.005.
0.005.
Huh?
0.005.
Yes.
I thought it would be 0.55.
No, it's 0.005.
Huh.
We just so
That's the last answer.
oh, okay. Okay, you're right.
And then 14 was a 0.995 or 0.955.
Okay, yeah.
0.995.
Okay, and then this one is 0.055.
Mm-hmm.
Yeah, 55.
Okay. Let's see how we did. All right, 100%.
Nice. Cool.
All right, cool. I'm gonna stop the broadcast right now, and then I'll post the link.